The last two club contest events, Freeze Your Butt Off in February, I guess it was. And at field day, a month or so ago, the antenna that was used was a End-fed Dipole that can be purchased from Illinois Precision.
Yeah.
Is that
End-fed.
right? That's right. The End-feds, and this is the model that has the matching transformer on the end to match the high impedance at the end of the half-wave dipole. This particular model has a trap. It's resonant 20 meters, and extension so you can operate at 40 and 10. And it worked quite well. Very easy to put up. No moving parts, no active parts, so it fits the bill for portable / emergency operation. Now, at field day, we did very well with that with a 100-watt sideband / CW station, but I couldn't help not focus on the ×5 multiplier for QRP. And I thought it'd be really nice to get that. And since we have a QRP heritage around here, I thought, well, if we just had an antenna with some gain, maybe we could do a decent job in the contest with QRP. And since I really liked what I saw for being just practical for port operation with these End-fed dipoles, I started leaning toward trying to do something with that. But before I get into this, I'm going to make 3 statements. I have my new frequency shifting hearing aid in my right ear, my left ear. My right ear can't hear at all. That means I can't really get a good read on what my voice volume is, because I hear it through the hearing aid. So if I kind of drift down to mumbling and you can't hear me, if you don't like it, I want you to raise both hands. And that's the signal that I got to speak up. I had hosted, I actually showed, a finished antenna, and I've put a lot of work into it last week, because I had to make a business trip last week, and so this is more of a progress report following Craig's good example. Also, my background is in physics, and I'm surrounded by what I think the majority is engineers. So I'm going to tell you a little story about the physicist and the mafia boss. There's in New York a mafia boss, mob leader, who liked to bet at the track. And he kept losing. He just couldn't pick the winning horse. So he talked with his lieutenants and other henchmen, and they said, look, you need to get some smart guy in here to figure this out. And I said, it's just all running the numbers, let's get a mathematician. So they went and found a mathematician, they brought him back to the big boss, and he says, I want you to use your math skills to be able to predict next week's winner. Mathematician said, no problem, it's just statistics. So he analyzed all the histories of racing the last couple of years and all the horses, and he came back and made his prediction. The next day that ran the race, his choice lost. Cement shoes, end of the East River. End of mathematician. So the boss talked it over again, and said, well, that was too theoretical, we need to get something more practical, let's get an engineer. So they did. They went out and rounded up an engineer, and they brought him in. He said, yes, I can do that. I just need to optimize the parameters and analyze the strength of the horse and bone density, and I can pick the winner. Later he made his prediction. Horse lost. Cement shoes, end of the East River. So they were really getting desperate. They said, well, we've got to get something that is down to basic knowledge that encompasses all everything you can. And somebody said, well, what about a physicist? Einstein was a bright guy, he was a physicist, just get a physicist. So they went and found one, and they brought him in. And they presented the problem to him, and he thought for a minute. And he went to a chalkboard they had there, and he looked the mafia boss straight in the eye, and he said, okay, it's no problem. First, assume a horse is a steer. Okay.
They have economist jokes like that too.
I like to tell that story about once every 10 years. So, but that's a little bit of a warning to you. You got a physicist looking at an antenna. Now, when I kind of looked around some of the recent literature in the ham world about what people were doing with some antennas that were similar to what I wanted, I was thinking about an array where you could switch the phase and rotate the beam. The auto rotor, nothing mechanical. In QST December 2011, some fellows in Germany, an electrical engineering student and a professor who happened to be a ham, came up with this inverted wire doggy switchable beam for 14 megahertz. I'll pass this around. There's a tower on top of their engineering building, and they've got 6 sloping wires coming off here on separate supports. And what they do is they take 2 they use as the driven element, leave the 2 on the side alone, and then the 2 on the opposite side they tune as a reflector or director, I can't remember which. And then they have a switching box up in the top of this thing that lets them switch this pattern at the station console around, so they have like 6 directions they can switch it to. Well, I'll pass this around. That's what these guys did. I thought for portable operation, otherwise it's too complicated. Then I came across this antenna in the QRP quarterly from winter of 2013. Some of you guys probably read this. It's refining an end-fed antenna. And this is kind of neat. And kind of clever what is done here. And I'm going to just briefly describe what's here, and I'll pass this around. And what I let me just, there we go. So really what my goal is to have something that works kind of like a 4-square antenna, which is a very popular antenna. If you've got a lot of property and a lot of radials in the ground, you have these quarter-wave verticals on the corners of the square. And of course, this is grounded, and you can control the phase of these and get an unidirectional beam out of that by switching the phase of these. But for those verticals, you've got to have a really good ground system. You're not going to throw this up the field base. Right. Okay. So let's talk about this resonant feed line antenna. There was an article by James Taylor, W2OZH, in QST back in '91 about similar antennas. So it's nothing new. And basically all it is you have a piece of coax with your connector on it. There's a little capacitor in here to help shift the impedance around. Talk about that. And this is just a halfway to 20 meters. And to kind of go Willie, he, does some not necessary connections here to get some more capacitance on the end, and shift the response around. And then in the center here, there's some connections that I'll talk about right now. So, what does he do? He's got his radio that's generating your RF, and he hooks it to his coax. Okay? And here. So, you know, in a perfect world, if you hook your 50 ohm resistor here, you can just have the RF on that coax line and down you go. And if you look at the field out here, and this is all doing what it's supposed to be, there's no RF out here. It's by good old Gauss's law, you've got a current going this way and a current going that way. So the sum of the currents inside that circuit is zero, there's no field outside. Right? So what this guy says is, look, the electric fields are between the outside surface of this semiconductor and the inside surface of the shield on this coax. So don't think of that as just a thin conductor. It's actually a pretty thick piece of metal. Okay? And so all the currents and the charges are on the inside of the shield. But there's the outside of the shield. He said, I can use that. So what he does is, this is half a wavelength, approximately. If you just cut this off, like that, then if you allow me to draw the currents here, some schematic way, you have the current here that are canceling, and this current is going to wrap around into this thing and also flow on the outside. Well, now what do you got? You've got these currents on the inside of the coax that cancel, and you've got the current on the semiconductor here on the outside of the shield that are just the same currents as a normal dipole. So you take this thing and you cut it here, and you connect the outer shield from the lower part that's closer to the rig. Well, you essentially break that. You connect the center conductor to the outer shield of the top part, because you already had this coax you're using. You could just use a wire. And you've got yourself a center-fed dipole that's end-fed, and you're not using a transformer like these guys do. These guys truly feed it at the end where it's high impedance. This fellow, AE6TY, Warren Harriman, is using the two surfaces of the shield so he can, it looks like it's end-fed, but it's not. It's center-fed.
Would you have so you have a connection, you didn't show it on the board, you do have a connection between the shield and the center conductor at the center point?
No.
You don't, you leave that open?
That's this open, this. Yeah, the feed line ends here, the same way.
Right.
If you had a, this
Okay,
is a regular
the shield is
dipole.
open, the shield does not actually physically connect to the center.
Right.
Right.
No,
I understand.
you just cut it, so the feed line ends here, and
Right.
the outer conductor, which is this piece,
Got it. No, I understand now. I
Yeah.
understand.
There, okay. All right. So, if you read this guy's paper, he puts it into, Easy Neck, or what do you wanna call it, Easy NEC. And he sees, you know, an impedance over a certain frequency range that's kinda over here. And then he says, okay, if I add a little extra bit on the feed line side, it rotates over here. And then if I put a capacitor in parallel at the end, it shifts it down this way so that I wind up over some frequency range having a little loop in impedance in the Smith chart that's pretty close to where you want it to be, and you got a SWR over pretty good frequency range. So these are the tricks he pulls to make this end-fed resonant line piece of coax behave better to give you a little bit lower SWR over a little bit larger range. And when you study these pictures, you'll see the response and you see how you put the capacitor in. It's a very clear article. This guy runs really well. Anyway, then he said, okay, so what he really does with the coax is he just cuts it here. And he takes this to here, okay? And then he says, oh, okay, well, so now I'm using the center conductor here, the inner surface for the feed line, the outer surface here for this segment antenna, and the outer surface here for this end, but I'm not really using the inside of this. Well, if I kind of cut this, if I just take these out here at some point and just hook all of these together, it kind of gives you a different little capacitance on the end of whatever, and it's just the SWR curve a bit. And it's not really necessary, but he just wants to tweak it.
Oh.
Well, it's stub-tuned, it's a coaxial dipole, it's
Yeah.
stub-tuned.
Okay, now,
Okay.
so here it is. This is your, and I took this thing up in the front yard and played around looking at the SWR and stuff. And it pretty much does what he said. Okay. So here's your kit for making your resonant line dipole antenna. You need you some coax.
RG 70s?
174. RG 174.
Yes, 174, just
So
because
that's
he's
tough
thinking
one,
QRP.
Oh, no, 174 is not, I'm sorry, that's the common, cheaper one.
Yeah, this is, but if you want to go higher, look, I want to get this thing up in the air. I want to put my radio right there. I mean, you could. But then he says, I want to bring my, I want my rig down here. So I want to have a feed line. Coax running up here, right? So how am I gonna, in a simple way, stop this? Well, he puts a toroid core here. He puts about 10 turns of his coax around it to give him about 130 microhenries of inductance, which is 13 kiloohms at 14 megahertz. So you need some of these to make this little, what do you want to call it? Stop? I don't know what to call it. You know, so you gotta add this to your kit, okay? So now you can have whatever length of feed line you want. And, this kind of, you got some turns, there's a picture in the, here, I'll pass this around.
What kind of toroid did you pick? What kind of material?
You know, it's one I got around. He said it had to be type 72 or something. Does that ring a bell?
72 is kind of hard to find, I think.
Well, here's the article.
Maybe.
And, pass that around. Now, okay, so Hulu's got a pretty cheap, easy to make, end-fed dipole. Right. Now, what about this? Okay. So, what I'm thinking is, and anybody who wants to jump in on this project and jump into it, it's quite well. Okay.
We got a couple balloons.
Well, for $100, you can buy enough telescoping, fiberglass tubes from,
Yes.
engineering to get it up 45 feet or something. That's all you need. So what we're gonna do. Ooh, that's a horrible color.
Yes, it is.
Here's the square, except now, because being on the ground, let's just draw one now. So here's your dipole, we'll put the vertical, there's the vertical dipole, and we keep this about, 3 meters off the ground, so we can walk underneath it and not get near the
Two's good enough for me.
voltage in the ground. And so you got that one, and then you wanna have, I'm not feeding it here, this is square, so right, this, we're gonna have 4 of these, okay? But it's too hard to support 4, right? So we're gonna have one mast, this will be the fiberglass pole, or you're lined up in your tall tree, and you just make them slopers. Put back there,
Yeah.
okay? So you got your 4. And you can either run the feed lines off of this end and bring them down, and this is gonna be, this is, roughly, well, this is about 3 meters. This is roughly about 10 meters.
So you use your antennas as your guidelines on your mast, right?
Hmm?
Use your antennas as your guidelines on your mast.
Yeah, you'll have an insulator here and an anchor to go to the ground, or a 3-meter post or something, but yeah, this is just me. Or you could have a water-filled bucket of kitty bucket.
Jay, by the way, that worked great.
Yeah.
It did. At Field Day, we had a
Yeah,
canopy and it was
I'll put it
kind of
here.
windy. To hold it down, he brought buckets full, empty.
His website won't take orange, so I couldn't.
Won't take what?
Wouldn't take my money.
Oh,
So, but I took the version that comes with the antenna book,
yeah.
okay? Oh, and I should say,
Elnick, right?
yeah,
Elnick is the free one, I think.
yeah, this is not the free, this is the
Okay,
$89 one.
okay, yep.
Yeah. But his version that comes with the antenna book, if you take those examples, which you can use, this has up to 500 segments, you can edit them, and as long as you don't save it, you can make it do whatever you want for free. So, but I should have said, when I first started sketching this out, I thought this is gonna be a piece of cake. And then I read chapter 8 in the antenna book, and I realized I was really wrong. Okay, the mutual coupling between these elements will eat you up, and you better have some modeling software to tame it. So that's another reason. So this is.
Roy actually wrote the antenna book too, by the way. I don't know if you knew that.
Hmm?
Roy Llewellyn, the guy that wrote Easy Neck, actually wrote the antenna book also.
Really?
He's the major editor of it, yeah.
Yeah.
He just redid it.
But if you read this thing, it's just full of the modeling software. And it's,
That's why.
it's totally different than what was in the antenna book 20 years ago, right?
Oh, yeah.
I still go by the old antenna book.
Is that right?
Yep.
Well, you don't need all the tools.
Well, the main thing is
Paul
that
never
if you
used
buy
this
this
either.
antenna book, there's a CD in the back with the software I'm gonna show you. It comes along with the ride. And if you wanna pay your $89 and get the one that's fully unlocked, you can. But there's also free ones out there. So somewhere here, did I click on the wrong one? Yeah, wrong, sorry.
Lights.
Click on the wrong symbol.
Where is it? Over here?
Yeah.
Around the corner there.
Where'd it go? Too many of them. Okay. So what I did is I took just the first example, which is just a dipole, and I took that dipole and I rotated it 89 degrees, so it became a vertical. You can't rotate it 90 degrees, software won't let you. Right? Or you could go in and just change the Cartesian coordinate source and the current source and you can control the phase on it. And so I did that and then I copied it and I put it here on the corner square and the squares on, instead of the four square antenna has a side of lambda over 4. When I put the first little cut I made with this lambda over 4, they were just interacting so strongly it was kind of weird. Maybe there's a solution there. But I expanded the square to lambda over 2 to get a little further apart. I thought maybe that'd make the coupling a little weaker. I was just kind of guessing. Anyway, here they are. And if you let's see. If you put two of them at the same phase, and then one is plus 126 degrees, another negative 126 degrees, you just play with these numbers. You get
Property of plot.
you get a pattern kind of like this. But this is by no means optimum. This is just the first stab. And then what you do is I did play with a little bit to see that if you tilt these things in 20 or 30 degrees, so that you kind of have the size of a pyramid, that this pattern doesn't change that much. Okay, so I think there's really hope that you could have a single mass or a single wire, so that this top can be about, say, 40 to 45 feet. And this is all very lightweight. And you do have, the little inductors to terminate your feed line are up here, but that's okay. And you bring these down. If you wanted to, you could have the feed lines coming off the bottom ends. But you just need your phasing network down here. And a lot of time with this software to figure out exactly what this needs to be to be able to steer this pattern. And mainly what I was looking for was 5 or 6 dB gain and a good front to back ratio. That's it. I think by taking this as your unit and putting 3 or 4 of these together, or however you want to combine them, you have a very portable antenna if you're willing to find the right tree to hold up the top. This fiberglass telescoping mask, I bought $100 worth of it and tried it at the house. It's slick as a whistle. I mean, it works really well.
Does it bend?
Hmm?
Does it bend, or is it?
It depends on how thin you go at the top.
Yeah.
If you get down to the 3/4 inch or so up at the top, but it won't bend when it has 4 guys coming off the top.
So you can meet all the way up to 40 feet without bending with the rig.
Without a side load on it, it's really good.
That's
if you have
friction fit
interest.
though, right? Is that one, you pull it up and twist it to fit it?
You pull it up and you slit the ends and you have a hose clamp to squeeze.
Well, you actually have a hose clamp on it, you're not just doing it with friction.
I mean, I'm on the house,
Because
I
those
lifted
would
this
have
thing
to-
up, and at one point, I had a mark a foot away from the end, so I know when to stop and not pull it down the bottom one. And I didn't see it, I went past it, and I pulled it up, and I had 30 feet of this fiberglass in this hand, and it was so light that it didn't, I was able to get it back down in there, and then snug up the clamp. And a couple of half turns on the clamp, but it's great.
Without the clamp, I mean, you'd have trouble supporting 4 wires, I think, but,
Are you talking about, you still talking about 4 wires off of one mast here?
yeah.
Yeah.
Or are you talking about 4 separate masts?
Hmm?
4 off one mast.
Yeah, the antenna doubles as guides to stabilize the mast if it's very thin at the top. But if you went just a little bit thicker at the bottom, so the top is still like an inch or so, some stuff's pretty rich.
So that you get all that portability, 40 feet without bending if you guy it, is what you're saying, with the DX model? That's a good one.
The tubes, the fiberglass tubes I used came from the Extension.
They work great. Okay.
Yeah, they work very well. But, so I'm not worried about, can you have the right mat, that's easy. If you have the right tree, you don't need the mat. It's the phasing network down here. Now, if you really wanted to take a big jump, you could have, I was gonna say, 4 separate little transmitters to drive them. Anyway, so that's the basic idea, and you can compare this. Let me open up the example that shows the 4-square antenna that people spend lots of time and money on for big home antenna phase. And let's see. As long as the file has this, oh, come on, where'd it go? Well, somehow I lost. Oh, it's here. This is a model that has, the feed lines and everything in it. Okay, and these are 4 grounded quarter wave verticals for 40 megahertz, 40 meters. And, you get that sort of pattern with, it says max gain is 3.5 dB, front to back is 25 dB. And then by throwing some switches, you can rotate that around by 90-degree steps.
We'll see one of those next month, I think.
Hmm?
He has a couple of them out there at the farm.
Okay, so we'll see some of those.
Yes.
Yeah.
What'd you use for your phasing network?
I'm sorry.
Did you buy a canned phasing network to phase
No,
your antennas,
no,
or
I
did you
don't
make
buy
your own?
anything.
Okay, and you're gonna talk about that, the one you made, or?
That's chapter 2. That's the next talk.
Okay.
They have no phasing network right now. Okay.
Uh-huh.
So, what I thought was going to be in my physicist at the radio approach, I thought this was going to be a piece of cake. Well, the antenna part I think is okay, and now we have to come down to earth and get the phase control going. But, read chapter 8 in this book. There's very good suggestions there.
Does the velocity factor enter into your equation for the F-wave,
Yes.
even in the antenna parts?
Well,
It has to.
It would have to, yeah.
in terms of in terms of the actual antenna element, yeah, 'cause I mean, here it is, it's made out of coax.
Right, okay.
You have to cut it to the right length, and that velocity factor has to be part of that.
Right.
And you cut that one's cut for 20?
This is cut for 20. So
Okay.
this is the halfway length at 20, and of course you can do it for whatever band. And you don't need, the upper half of this doesn't have to be coax. It could just be a normal white. So,
So going to the outer shield instead of the center conductor, was just for added strength, or a little more robust conductor, is that it? A little bit more metal out
on
there?
the top?
Yeah.
On the top half?
Right. So you went from the
he
center
didn't-
to the outside. I wonder what
He
the
did
reason for that was.
He did that just to make a tiny little change in the SWR, the function of frequency by, it acted kind of like a little capacitance hat or something.
It's probably, once again, it's, but that's the velocity factor right there again. I mean, it's the thicker metal, right? It's a bigger conductor, I think.
Right.
So, that's confusing.
Well, on that little bit, and he says he says, look, you don't really need to do this.
Yeah.
He says, but I had that extra surface, those extra surfaces I'm not using, I'm gonna play with.
And then the center one's dead after that. It's dead.
I'll go
That's-
back. This is your freebie, this is the freebie model you're using,
Yes.
or is it?
Yeah, the freebie model
This
has.
is easy NEC ARRL.
Yeah.
You just can't save them then, right? Is that what you
Well-
said? The freebie one?
Yeah, the demo you can download for free for
Yeah.
Easy
You
NEC.
get 20
It's
segments
limited to
on-
20 segments.
Yeah,
But the one that comes to ARRL, there's special data files that have ARRL in the name, and those can have up to 500 segments, but you can't change them and save them.
Yeah.
Okay.
But you can change them without saving them.
Just for the,
Which I discovered this morning at about 6.
it's,
Really, that's it. I'd hope to have,
Roy explains this so well too, by the way, if you ever catch him at Dayton or whatever, he's always there in his booth, doing models for people, showing them how it works. He's a fantastic guy.
this
He's
is, well, and
down to earth as you can get, and he's
do you know the
he's
history
a
of the
great friend.
NEC code?
What's that?
Do you know the history of the
Well,
NEC?
he did it as a commercial thing, he has a bunch of
No, but
commercial
before
customers.
him.
Well, he got it from NEC, you know, he got the engine from them, he done it for the government.
Yeah, what I'm asking is, what's the history of the NEC engine?
Oh, that's a government project. I
From the
think.
70s or 80s?
Yeah, it was all funded by the taxpayers, so.
Okay. See, this is
But
in
he
public
worked-
domain.
It is in public domain, and the basic thing that EasyNet does is puts a user interface on that's easy to use.
Yeah, and there's some guy in here in Minnesota, I met him
Yeah,
at
neck to
End-fed.
go.
Hmm?
Pat,
Pat.
neck to go. Yeah, it's a
Yeah.
way better product in my opinion.
Is that right?
Oh, really?
Try that one.
Well, what Pat does is he coded in an optimizer.
Okay,
Okay, so you don't think around with changing parameters manually. What you do is you
Okay.
push a button
really?
and it sweeps and it runs an optimizer.
Okay. All right.
And so it figures out the links. It can optimize coax, optimize antenna length,
Really?
optimize
Is this
antenna
right?
height.
Is this the name?
Yes.
Really?
And he also takes into account
Is the homegrown?
velocity factor in a way. I'm not sure how you do an easy neck. I haven't found it yet, but anyway, for $40,
That's
this
what it
guy's
is.
a Minnesota guy and
Really?
he's a mathematician.
Oh, I need to check that out. That's good to know. Thank you. That's,
But from the physics point of view, if you want to go back, my old professor at Penn State used to get on to me for peeing around with radio. That's what he described it, being allowed to make it a radio instead of doing our experiments. And the physics buried in this thing is just phenomenal. There are lots and lots of physics here at a very deep level.
Where you're smart.
There's a,
Where would we be if we didn't spend our time peeing around with radios?
Yes,
Yeah.
that's what you get when you pee around with radio.
That's
there's
right.
a reflector out there with a bunch of theoretical physicists on there that's all they do is they think around with this kind of thing. So, you're not alone.
Well, I've never played with it. I'm just starting, and it looks like a lot of fun. And especially if we by next field day, we could go truly QRP battery operated.
That's the other club, Tom. I'm just kidding, I'm just kidding.